All right, how's it going, everyone? So you've had some time to work on this activity in your groups, and now we're going to do a debrief. It's going to be the same type of debrief that would happen if I was in person. I've just pre-recorded it. And so I've kind of written down some sample answers that I think that most students would have come up with for these 5 questions. All right. So first, our learning target. So we want to apply properties of lines and angles to prove claims. Right? So the rest of Unit 3 is all about logic and reasoning, and eventually we want to be able to write what's called a 2-column proof. Okay. We're not at the point yet where we can write a 2-column proof from scratch, but we're going to be filling in gaps of some proofs that have already been written. Okay. All right. So let's look at some properties about angles, right? All these questions have to do with angles. Okay. All right, question number 1, which of the 4 angles are congruent? Explain your thinking, right? Well, I see that all of these angles have that green square, right, in the corner, which implies that these are all right angles, right? And we know that right angles have a 90-degree measure to them, right? If we took a protractor to each of those angles, it would always measure 90 degrees, okay? So since all these angles have the same 90-degree measure, they have to be congruent, right? That's the definition of congruence, having the same measure. All right. So this idea that right angles are always going to be congruent to themselves, I know it's kind of stating the obvious, but we have a formal name for this idea, okay? It's called the right angles congruence theorem. Okay? So grab a red pen, and in the margin here next to question 1, write down right angles congruence theorem. All right. Question 2, we want to list all the words that could be used to describe these 2 angles. Okay, and so some of the words that I thought you would have come up with are linear pair, supplementary, or that the sum is going to equal 180 degrees. Okay. So all of those descriptors are appropriate for this image here. Okay. Now it turns out that anytime we have a linear pair, it'll always be supplementary. Okay. Every linear pair in the universe, right, is going to be supplementary. Okay. And so the fact that that's always true, we're going to give that a formal name. We're going to call that the linear pair postulate. Okay. And so again, this just refers to the idea that every linear pair in the known universe is supplementary. All right, question 3. We've got a pair of lines that intersect and that form these 2 angles, angles 3 and 4. How can we describe those angles? So number 1, we can describe them as a set of vertical angles. Okay. Any angles that are across from the same intersection point are called vertical angles. Okay. And we learned back in, I want to say Unit 1, that vertical angles are congruent. If we took a protractor and measured angle 3 and measured angle 4, we'd get the exact same measurement. Okay. So vertical angles are congruent, which means they have the same measure. All right. So this isn't just coincidence, but it's always true. Anytime we have a figure that contains vertical angles, those vertical angles will always be congruent. Okay. So we're going to formally refer to this idea as the vertical angles congruence theorem. So questions 4 and 5 were a little bit more challenging, right? I described them as being kind of like a riddle, like a puzzle you got to figure out. Okay. So here's what we knew, right? Angles 5 and 6 are supplementary. Okay. So based on our vocabulary knowledge, we know that means they add up to 180. Okay. So I wrote that as a mathematical statement, right? Angles 5 and 6 add up to 180. We're also told that angles 7 and 6 are supplementary. So I just converted that to a mathematical statement as well, right? angle 7 plus angle 6 equals 180 degrees. Okay. All right, and then next I did some rearranging, right? So I rearranged the first equation, right, to isolate angle 5. Okay. And so now it says that angle 5 is equal to 180 minus angle 6. And then I rearranged the second equation in the same way, right? I wanted to isolate angle 7. Okay. So angle 7 is equal to 180 minus angle 6. Right? And then I realized that these two angles are equal to the same thing, right? They're both equal to the expression 180 minus the measure of angle 6. Okay? And so that tells me that, well, angles 5 and 7 must be the same as well, right? It all goes back to that transitive property, right? If Al is the same age as Bob and Bob is the same age as Carl, then Al and Carl must be the same age. Okay? We're using the same type of reasoning here. Okay. All right, so we're going to give a formal name to this idea that two angles that are supplementary to the same common angle must be congruent to each other. This is called the congruent supplements theorem. And now we get to question 5, which we're going to use similar logic as we did to question 4. Okay, the only difference here is the word supplementary has been replaced with the word complementary. Okay. All right, so the riddle begins by saying that angles 8 and 9 are complementary. All right, we know that that means that they add up to 90, so we can write that as a mathematical statement. Okay. The riddle goes on to say that angles 10 and 9 are complementary. So again, that means that they add up to 90 degrees, and we can write that as a mathematical statement. Okay. And now, just like we did before, we're going to rearrange those statements. Okay. So we can rearrange the first equation so that we isolate angle 8. And so the other side of the equation is now 90 minus angle 9. And we can rearrange the bottom equation to isolate angle 10, and we end up with the same expression on the right-hand side, okay? 90 minus the measure of angle 9. Okay? So now I see that angles 8 and 10 are equal to the same expression. They're both equal to 90 minus the measure of angle 9. Okay? So by using the transitive property, right, if Al is the same age as Bob and Bob is the same age as Carl, right, then Al and Carl must be the same age. Or in this case, angles 8 and 9 must have the same measure. All right, so, sorry. We're going to refer to this idea that two angles that are complementary to the same common angle have to be congruent. That's going to be the congruent complements theorem. That's the name we've given it. So in total, right, we've seen 5 different theorems or postulates about angles. Right? Some of them kind of obvious. Some of them we need to think a little bit more deeper on. Okay, but number 1, right, all right angles are congruent to each other. Number 2, linear pairs are always supplementary. Number 3, vertical angles are always congruent. Okay, number 4. Okay, 2 angles that are supplementary to the same common angle have to have the same measure. And then number 5, 2 angles that are complementary to the same common angle also have to have the same measure. So now let's organize all of those angle theorems and postulates in one spot, and that's going to be our quick notes. All right, so let's start with that right angles theorem. Right angles congruence theorem. Right. So the big idea here is that all right angles have the same measure, so they're all congruent to each other. All right angles are congruent. All right, let's record kind of the big idea about the linear pair postulate. Okay. And so all this refers to is the fact that every linear pair in the known universe is a set of supplementary angles. So linear pairs of angles are always supplementary. And then thirdly, we had the vertical angles congruence theorem. Right, which simply refers to the idea that every set of vertical angles in the known universe are congruent. Okay? Or in other words, vertical angles are always congruent to each other. Right, so those were the first three, probably the more important three. Okay. And then we had two more, okay, one about angles that are supplementary and one about angles that are complementary. All right, so let's write congruent supplements theorem. Okay. Now here I'm going to try to be a little bit more illustrative, all right, or give you more visual argument. Okay. All right, so let's say I had an angle, I'm just going to call it angle 1, okay, and then I'm going to make an exact copy of that angle. Okay, so really I have two copies of angle 1. Okay. On the first copy, I'm going to draw an adjacent angle, but I want to do it in such a way that it makes a linear pair. Okay. All right, so I'll call that angle 2. And on the second copy, right, I'm going to do the same thing. I'm going to draw an adjacent angle, but I want to do it in such a way, right, that I get a linear pair, that I get something that's supplementary. Okay. Now visually we can see, well, angles 1 in both diagrams have the same measure, and these are both linear pairs, so they're both supplementary. So it seems logical to conclude that angles 2 and 3 would have to have the same measure. Okay. Angle 2 would have to be congruent to angle 3, right? Because both angles 2 and 3 form a linear pair with angle 1. Right, and then let's look at the last one, the congruent complements theorem. Okay. And I'll give you the same kind of visual argument. Okay. So let's make an angle, and I'm going to call it angle 4, and then I'm going to make an exact copy of it. Okay. So I have two copies of angle 4. Okay. On the first copy of angle 4, I'm going to draw an adjacent angle so that I get a right angle. Okay, and so let's call that angle 5. And on the other copy of angle 4, I'll do the same thing. I'm going to draw another angle, right? But I'm doing it in such a way that I get a right angle. So now I've drawn two new angles, angle 5 and angle 6, right? But they'd have to be the same as each other because both of them form a right angle with angle 4. So in other words, angle 5 would have to be congruent to angle 6. All right, so there you have it. 5 new theorems or postulates about angles, and now we're going to be able to use these theorems to help us write two-column proofs. All right, so what I'd like you to do next with your groups is work on these check your understanding questions. So in the first one, there's 3 missing parts to the proof, 1 missing statement and 2 missing reasons. There is an answer bank here, so make sure that you're looking at the answer bank as you're filling in the missing parts of the proof. And then same thing with question 2, except there's just a greater number of missing pieces. But again, you have an answer bank to help you. Make sure you're trying to put things in the right order, right? Order is important when we're doing proofs. And then finally, the last question, you want to use that linear pair postulate or that vertical angles theorem to set up some equations to find the values of the variables x and y. All right, so good luck with that. I'll post an answer key to these check your understanding questions in Canvas. I'll do that after B-Day. It's a Friday by the time you're watching this, so hope you guys all have a good weekend.